Assalamu alaikum warahmatullahi ta'ala wabarakatuh, ladies and gentlemen. Welcome back to another live stream. Let's go. Okay, let me share the live with my server, and please make sure to join my server so you can actually vote on next live streams and on all sorts of craziness. And also you get notified every time I do a live stream. Alright, so let me share the link, and there you go. Pretty cool, seems to be great. Alright, okay, so today we have a big change of plan. So we're gonna be removing Lua. We're also gonna be removing GLFW. I'm gonna replace GLFW with what is it even called? With SDL, right? Because I just realized since I'm using C, I do need a lot of other crazy stuff. So we're gonna be using SDL. And also another change of plan, which is that I'd like to architect my engine much better than I was going to do. So the engine would be actually compiled as a DLL, just like Unity does it, and a lot of other games and engines does it. For example, Quack 3, I believe, actually uses that. So it just compiles their engine into a DLL. And basically we're also going to have the game itself as a DLL, which is going to be written in C, Zig, or whatever. Doesn't matter, as long as it's a DLL. Our engine would go ahead and essentially load that game at runtime. And since we're going to be doing that, we're also going to have hot reloading. So basically, instead of making in scripting and making our engine an executable, for now at least, the idea would be to actually make our engine a DLL, and to make our game also a DLL. And by doing that, we're allowing a lot of cool things. For example, you could just, to program your game, you could just use whatever language that can emit a DLL, which, for example, Zig, C, C++, doesn't matter. Any compiled language that can compile to a DLL, a compatible DLL, of course. And that's the first thing. And second thing is that we could basically later on, like, we could reuse that DLL for both the game, the editor, for the game and the editor, basically. So that is actually very interesting. Thanks to my server, thanks to WindRammer, to actually, it's like we were having a conversation and I kind of got inspired to that. He actually mentioned that at first. He mentioned, like, here we go, simple C hot reload header only library. But then coming to think about it, I have just got inspired at some point, and I also remembered that Unity, for example, have a DLL too, like that runtime DLL thing. So it was a very interesting thing, and hopefully we're gonna try today. We're gonna try to set up everything today. So pretty much, of course, we're almost starting from scratch. Thankfully, we didn't do anything much in the previous episode, just, you know, setuping, which we are still gonna have. Not much gonna change on that. And also, most of the time that we have spent in the last live stream was just basically downloading and installing our tool chain, and in, you know, setuping our build system. Other than that, it was mostly just spending time on Lua. So the first idea was that I would just get rid of Lua for now, at least, so I could focus on the engine more. But then we had that conversation with, I had that conversation with WindRammer, which actually inspired me to even go further with such cool stuff. Okay, Yo Man 3D, welcome to the live stream. Finally started regular streams, yeah. So it was basically I was sick at some point after the Codoxel stream. I was pretty much sick, but then I recovered after a while. But then I was too lazy to start live streams, but here we go again. I got inspired again. Okay, so let's get into it. I'm very excited for today's live stream. This is gonna be very interesting. Okay, pretty cool. Alrighty. So first of all, let's actually include SDL. SDL. And since we're using C, the C language, which doesn't have a great standard library, SDL would be very useful for us. So yeah, while GFW only gives you you know, a screen and input, that's pretty much it. So yeah, we cannot work with that. Okay, let's have a look into where SDL is. Hold on a second. Where's the GitHub? There you go. Okay, pretty cool. I think it is good to use C++ because of templates. Now the thing is, one of the amazing things about using C is that you don't actually get lost in the stupid language details. And we also get like, because I'm going to be doing hot reloading and all sorts of DLL magic, C++ won't be in the way, since you gotta care about mangling and ABI compatibility, etc. But that's basically free when you're using just C, and also C basically can run on any stupid machine, right? But yeah, but you could at any point just mix and match basically. But anyway, so yeah, pretty much. Okay, simple direct media layer, and in fact I don't think we need templates really, but anyway, that just, at least for the engine. I'm not sure about the game, but I mean, as I said, you can use whatever language to actually program the game, hopefully, if the plan is going right. Okay, let's actually install this guy. So you just copy this guy and you put it here. So, well, let's see. CPM add package. As you can see, CPM is very straightforward. So yeah, GH, just like that. And then let's grab the tag. If you guys have any suggestions or questions, please let me know. Like, since I'm just starting the engine, it's very easy to switch the direction at any time right now. But then later on, when we become really serious and deep into the engine design, it becomes very hard to change. So yeah. Alright, so as you can see, it's adding the package. It's that simple. And right now we got SDL. And I think I'm going to be using SDL3 for now, unless if we got a problem with it, since it's still in development. But so far, I used it before and it was pretty great. It worked just fine, but we'll see. If it doesn't work, we could easily just go back to SDL2 and use that. But yeah. Alright, pretty cool. Build files have been written to, pretty nice, lovely. Now let's actually link to SDL. So you just say SDL3 like this. Oh well, we gotta actually set up that build stuff that I talked about, which is to make the engine a DLL. So let's see how we can do this. Well. So I'm going to switch this to, hold on, let's see. Yeah, I'm gonna switch this to, instead of an executable, we're gonna create a library essentially. Project name, target sources, private src main.c. And it's gonna be a shared library for now, though you could probably still use it as a static library if you want to rebuild the engine. But anyways, private source main.c, private, pretty cool. Private GFW include none. Lovely. So yeah, that's pretty much it. I'm not sure if we really need SDL3 main. I don't think you need that in SDL3, but we'll see how it goes. Other than that, right now we need to create a new executable, which is going to be our... Actually, we need another library first of all. Yeah, we're going to need another library. Well, really? Yeah, we do need another library, which is going to be project name. Well, it's going to be game for now, I think. Though this would be just like some sort of a test game in some sense. Or we could use it maybe to like just like how Godot engine does it. It's like they have their engine, but then they use their editor to like they use their engine, the engine itself to create the editor. So we could also go ahead and do that too, which would be quite nice, I guess. All right, fine, why not? So we're gonna create add library editor, project name, editor, and then what else? Let's see. And then target sources. Oh well. And then what is the sources? Well, we're gonna have another folder. And this is gonna be, I believe, editor maybe. The editor, and we're also gonna have the, let's see, I guess the engine, right? All right, interesting. Editor and the engine. And then I'm gonna have the launcher, I believe. Is it? Though I don't really need to make the editor a library, honestly. Maybe I could be just an executable anyways. Actually, no, you need that, right? Yeah, you need that. So just like a game, basically. So engine and the editor. So we're gonna have here src, I believe. So new folder, I believe src, and then you'll have like a new folder include, I guess. And then here you'll have just like new file editor.c, and that's basically it for that one, I believe. And maybe an include, not sure yet, but we'll see how that goes. Okay, so editor target sources would be editor, right, editor slash, I believe src, right, slash editor.c. all right, what else? Well, of course it would also have kind of a similar thing there. No, okay, nice. Other than that, what else? Well, let's make sure that the target is correct. And that is the editor. It's also going to be a library. Now we need some launcher. And that launcher would actually have the main thing, right? Alrighty, interesting. Let's see. Where is the engine, by the way? Here, okay. So the engine would have an src and an include, okay? An src and an include. And of course it would have like engine.c and engine.h. And of course we do need the include, as we're gonna see in a second. Other than that, what else? Engine. So instead of src main.c, now we have became engine. Now I'm going to actually decouple this into multiple CMake files later on. But yeah, so engine slash src slash engine.c. And then of course target include directories. It's gonna be the project name. So basically the engine is called with the name of the project, which is Codoxel. While the editor would be called Codoxel editor, basically. But you got the point, hopefully. I never really seen anyone do it like that, but I mean, I do see the other engines using DLLs and crazy stuff like this, but for someone to actually explain how that works, I never really seen that. Anyways, so all right, we'll see, and hopefully we can get hot reloading working too because of this architecture, but we'll see. I never really have done this before. Like, I just got this idea and we're gonna test it. So yeah, so engine slash include, that's the target include directories. Now what else? I think we're done hopefully with that one. Add library. Alright, so that's the engine basically. Well, engine, and then this is gonna be our editor. We're gonna, as I said, decouple this into multiple CMake files. Alright, and then we're gonna have the launcher, I believe. And for the launcher, let's see. Well, actually we need two launchers. One launcher for the editor, and one launcher would be just for the game that you actually distribute with your game DLL, basically. So we're gonna have like an editor launcher, essentially. And this would be the actual executable. And it would just have like a main function, and that's it, basically it. Though honestly, we could have one launcher which would look for the which can launch the editor or the game. But honestly, never mind. Let's just do both. Okay. So now, project name, editor, launcher. This would basically just bootstrap and load the actual engine editor. Or actually, it would actually load like the engine. It would just initialize the engine, and then the engine would go ahead and load the editor or the... Oh, interesting. You would load the editor, or... So we actually need one launcher, but how are we going to do that? Interesting. Hello, Ridwan Karti. Welcome to the live stream. How are you doing? I'm great, thank you. Thank you. How is it going? Add executable, project name, launcher. I'm trying to think this through. Launcher. Alright, sure, why not? Let's just see how that goes. We'll see how that goes. Project name and launcher. And this would actually be the actual src slash main.c. Basically. So yeah. Yeah. Target sources and then target. What else? What else? Now, of course, I'd like to get my beautiful compile flags. And also, I almost forgot about target compile features C standard 23. Let's go with that too, why not? Though I should be careful with the copy pasting, since I have to make sure it's correctly done. Let's just copy this target compile features and copy it here too. And here we're just going to use launcher instead of editor in this case. And yeah, oh my god, I almost forgot about that one too. Alright, so I think we're pretty much done at this point. So we have our, basically we have our engine, which is going to be a shared library. And our editor, which also going to be a shared library. And what else? And of course our engine would link to our libraries, GLM, Volk, etc, etc. Our editor would have to link to the engine, but I don't want to actually link it directly, like hard linking it, I believe. I guess I'd like to use maybe runtime linking or something. I don't know. We'll see. So yeah, I think that's pretty much it. Let's try to run this and see what's gonna happen. Alright, so what's happening here in configuring incomplete? What are the errors essentially? Let's see. Build finished with exit code -1. Build finished with exit code -1. What? Clear output. Let's try again. Exited with code 1, but why? Oh, target sources called with invalid arguments in line 60, I guess. Oh, I see. So we have some. Oh, I see. I forgot about private here essentially. Private here too. Right. Let's see now if it actually worked. It seems like, I guess. In main.c. Well, that makes sense because this is not supposed to be here. This is supposed to be in the actual engine. So engine.c. And now here in engine.c, essentially in engine.h, we're going to have, I believe, init engine basically, or engine init. So it's gonna be like void engine init, I think, or not sure exactly, but we'll see. And then we'll basically have, well, I don't want to actually, yeah, I'm just gonna have the declaration here basically. And then here I'm gonna say void engine init. And here where I'm actually going to include my libraries, etc., right? Pretty cool. ISO-C requires a translation unit to contain at least one declaration. No previous prototype for function. Oh yeah, I almost forgot. So engine.h, we should have pragma once, that's for sure. And what else? And here we gotta include our header. So engine.h, I believe. Oopsies, not in main. In engine.c, right? So here we're gonna basically have this. And I guess let's try again maybe. Alright, let's see what's gonna happen now. As you can see, it's building, I guess, SDL. But something happened wrong, of course. Let's see. No new line at the end of the file because of Unix. Right, that's pretty much just a compatibility thing. And there you go, SDL is actually being built right now. The nice thing about having SDL in your source code is the fact that it just works with CMake, and when you debug your code, you can actually debug through SDL and see what SDL does too. If you want to, which is pretty cool. So as you can see right now, it's working just fine, seems like. Nice. At least it's compiling, right? No new line in the end of file. What a nice error. Yeah, it's pretty much right there for I believe legacy reasons, where I think Unix systems had a problem when files didn't have a new line at the end, basically. But yeah, something like that. You can search it up. Anyways. So other than that, let's try right now maybe to start our launcher possibly. Okay, let's see. Include, I believe, let's go with engine.h, right? But in fact, we gotta actually share, we gotta have access to engines includes. So how are we gonna do that? Engine includes. Oh, that's interesting. Should we have like one include folder for everything, like, or actually maybe not. Let's see. CMake and here in my launcher, I believe, because I do need the header file. I'm not going to be linking directly to it, but I need the header file. So here's how we're going to deal with that, I believe. So target include directories, project name launcher, and we're going to have it include the engine, I believe, / include. And now hopefully we should have access to that header. Okay. Now if he's not here. Now, as you can see right now, there you go. Nice, lovely. Now I could hopefully call engine init here. But of course I cannot because I'm not linking directly to it. So what I really need to do right now, in fact, is to go ahead and load the library. Now the problem is here is loading the library is not something that I have to use. For every platform you have a different way to load dynamic libraries. So let's just go with Windows for now. Define Win32 lean and mean. And this is why it's good to have some low-level knowledge about how everything works. Otherwise I would be clueless at this point. I mean, I could embed the whole SDL into my launcher, but that is not very nice, I guess. So define no min max, define Win32 lean and mean. Alright, that's pretty cool. So include windows.h, pretty cool. Okay, so now we're just gonna say load library. Well, this is gonna give me a handle, I believe. It's gonna be like library equal to, but of course this would be only if def win32 and if. Otherwise for Linux we're gonna have to do some other stuff, which I wouldn't do for now. So handle library, okay, Lloyd library W, and here I would actually give it the name. So we're gonna be loading engine.dll, hopefully. Incompatible pointer types initializing handle. Oh yeah, I think it's like this basically. Right, lovely. And can I just say const? There you go. Now we got the library loaded in. And what else? I saw you discussing this card earlier. You're basically gonna focus on one platform for now, right? Well, I think I'm gonna make it work on Linux too. So at least Windows and Linux. But for now, I'm just gonna focus on making it work on my machine. Alright, so that's pretty much it. But I can guarantee that we're gonna support Windows and Linux. Possibly Mac OS, but I don't want to really limit myself to that. And possibly even other platforms. But again, as I said, I'm not really want to limit myself because of cross-platform or old hardware or whatever. But we'll see how it goes. But for now, I'm just gonna go with Windows. In fact, I'm working with Windows right now because most people actually use Windows to do gaming and also to do graphics development, and that's why I'm on Windows right now. But you would usually find me on Linux. But anyways, load library W. Okay, so right now this is supposed to load the dynamic library, the engine. Now next up, we need to actually get some symbol. So how are we gonna deal with that? Well, let's see, that is interesting. Let's go back to engine.h. Let's see what we could do about that. So maybe let's say pfn, well, type def, I believe. Pfn, well, it's going to be actually a pointer to a function, right? So it's going to be, well, it's going to be void, right? And then we're gonna have the name, which is just gonna be pfn engine init. I'm also honestly going to do it like this. And then this would basically be engine init, I guess. Nah, actually we don't need that, right? We need the arguments, right? And for now we're just gonna have void here, right? Pretty cool. And that's essentially it. Engine init. Or can I just say maybe a pfn engine init? Engine init maybe equal to null ptr or something? Nah, that doesn't make sense, does it? Interesting. No. Keep it as it was, please. Alright, pretty cool. So now let's go back. Even if you are not planning on making it cross-platform, it's good to design the engine in a cross-platform way so you don't have problems if you want to make it later. That's exactly what I'm going to be doing. For the engine itself, that's exactly what I'm going to be doing. Yes, I'm going to have it relatively cross-platform with our... but I'm not going to care really about it right now, essentially. So, yeah. For example, let's say I want to use some Vulkan extension, okay? And that extension isn't supported on macOS or Android. I don't want to limit myself from using that extension. That would provide me with much benefit in this platform, just so I can support other platforms, basically. But anyways, so engine init now, pretty cool. So that's basically it. Basically. So now let's go here. Now we're just gonna say void. Well, actually not void. We're gonna say pfn engine init. Engine init is equal to dl. Well, not dl. It's gonna be, what is it called in Windows? Well, at least in Linux, it's basically dlsym. Lloyd symbol or something. Let me actually see. Hold on. Nah, it's fine. If you have any questions or suggestions, let me know. Right. So let's look for Lloyd function. Lloyd library, Win32. Okay. Let's see. DL main dynamic link. Get proc address. Oh yeah, I forgot about that. So it's basically get proc address. Then here you give it the H module, which is in my case is library, and the lpcstr. Oh my, I should make sure to use W there. And then here the proc name, I'm gonna be Lloydin engine init symbol, and then I'm basically gonna be calling that, I believe, use if in declared identifier. Did you mean get proc address? Oh, what? Oh, so it can't be that way. Alright, interesting, makes sense. Alright, what's else? Incompatible pointer. Well, we're gonna cast that. We're gonna cast it to pfn engine init. And now cast from var proc to covered to incompatible function type. Okay, that warning is very not so useful. Cast from long void to pfn engine init. What is that error called, by the way? Let me see, hold on. Let me make sure to change the target, by the way, first of all, to Codoxel launcher for now. And let's just see what is the error. So non-portable path to file. Oh well, okay, fine. Let's just call it that then. What else? So as you can see, this is the error. And I actually don't care about the error, so I'm going to add it to my list of in useless errors. Let's go. W no. Cast function type strict. And let's see. And there you go. Lovely. So let's go back now. This should be fine now. Let's go. So right now we're actually calling our engine init through the DLL without linking to it. So right now let's see if this actually works. So if I actually go ahead and include let's say std_lib, or actually let's include SDL directly maybe, or you know what, let's just go with stdio for now to keep it simple. And let's just say printf, and let's see if this actually works. Alright, let's see. Oh, what? Interesting. It actually returning an error for some reason. Why? And failed exit code 1. Use of undeclared identifier. Quick fix. Include stdlib.h. And let's see. I forgot to actually do some error handling though. I should make sure that this is actually being handled correctly. So if not library, then we're going to basically say if printf is it, if printf, right, and the file is essentially library, well std error, right, and then here cont Lloyd engine.dll. Should check engine init is not null. I should check the library first of all, right? And then let's actually load this guy too. It's probably failing to load the library, and I know why. I think we'll see how that goes. Access violation, what the? What? Should I like use winmain? That's gonna be weird. Okay, let me see what's happening here. Okay, as you can see, couldn't load engine.dll, and I think I know why. The thing is, if we go to build folder, right, you're gonna see, well, where's the launcher? Where's the launcher? Codoxel launcher.exe. But well, there's also the DLL there, interestingly, but I still couldn't find it, is it? Where's the engine DLL though? Interesting. Where's the engine DLL? It doesn't seem like it got... Should I like install it or something, I believe? Yeah, maybe. Maybe. There's no engine.dll. Yeah, I see. But for now, just to force it to build anyways, I'm just gonna link it to what we're trying to do right now. We're gonna try to link it to just the editor for now. We're not gonna link it to the launcher, which we're actually testing right now, just as a temporary fix. Though I believe there's like install targets or something like that. I never really used this one. Specify rules to run and install time. Install targets. But anyway, let's just do something that I know for now. So target, link, libraries, project name editor. Just as a, oh well, the actual editor is also a library. Oh well, hold on. Okay, I'm just gonna do a little workaround because I don't exactly know how you can actually force the target to build regardless. So I'm just gonna do a little executable real quick, and I'm just gonna say target link libraries, just as a little workaround. Target link, though I'm not sure if, well, we'll see. Target link libraries test and private, and we're gonna say Codoxel, well, project name basically. And yeah, now I guess maybe I need to build a test thing, right? Oh well, it's gonna tell me that it couldn't find any stupid source files. Yeah, yep, no sources given. Oh well, oh well, oh well. Okay, I need to search, honestly, I need to research on CMake on how you can install basically a DLL. I don't want to link it directly. So how to install a DLL in CMake without linking, if that makes any sense. Let's see. Honestly, let me try one AI that I have here on Brave. I told you it is install, but I never used that function before. Copy the DLL file to the installation, but no, I don't want to copy it to an installation directory. Well, the installation directory would be, oh, I see. Now that's interesting. Okay, let's see. Okay, CMake to link to DLL without lib. Anyone knows how to do that? Let's see, target link libraries. Although I could work around on that by just making a dummy source file. That's not what I'm looking for. Okay, let's look for CMake install. Targets. Well, yeah, I have a target. Specify the directory on disk to which file will be installed. Nice. Configurations. Yeah, probably I need this guy. Okay, let's try it out. So essentially install, and how you do it, I think you say targets maybe, and then in my case I'm going to try to install the engine, which is basically called with the project name, which is Codoxel. Let's see what it's gonna do. Did it actually did it? Let's see. Let's actually build this. Or maybe I have to build all or something. Hold on. Let's see what we have here. There's an install target. Let's try that out, I guess. Did that work by any chance? ISO C requires a translation unit to contain at least one declaration. What? Well, just ignore this guy. Editor.c. I don't want to deal with editor right now. I'm not using the editor yet. So just targets project name. Okay, let's try this now. Install the project. Failed. Exited with code 1. And it's not really giving me any kind of clear error, no? Oh, it's actually trying to install the Codoxel launcher, which I don't want to do that. That is very weird. File cannot create directory. Program files Codoxels slash. Oh my god, it's actually trying to it's trying to put it in my program file, so in my system, right? Well, no, I don't want that. Let's see, can I actually tell it exactly where to put it? Destination, I believe. Yeah, probably destination. Let's see. So maybe destination, and then destination would be build, I guess. Well, how do you actually do it? I believe it's basically cmake current binary there, maybe slash bin possibly. And let's see, hopefully that would work by any chance. Well, we got something new. Oh my god, let's go. We got codoxel.dll right there. It seems to be working. Nice. So that's how you install a library without linking it to your executable directly. But the problem now that we're gonna have, either way, even if we actually go ahead to, where is it, to actually Codoxel launcher and we try to build that, we're still gonna have that error. And you know why? Because they're not in the same directory. This guy is in this directory. So how can I fix that? Well, the workaround that I've found, some people, most people I guess, font too small. All right, thank you for letting me know. Here you go. Hopefully that is enough. So most people, when they come to this problem, they just do file copy and they copy DLLs around, which is very strange. But personally, what I found that works for me, I guess, which is just setting cmake, I believe it's binary there. Yeah, well, not binary there, runtime, I believe. Yeah, output directories. Okay, so I just set all the output directories to my thing. So for example, runtime output directory, I would set it to that guy, let's say. But in my case, I don't really care about that. In fact, what I really care about here is executable output directory, I believe, isn't it? Hold on, output directory. Yeah, it's pretty much runtime actually. Yeah, probably runtime. So let's try that out, hopefully. That would be nice too. And let's go. Codoxel launcher.exe right there. Nice. Lovely. But it's not called engine.dll, it's called Codoxel. So as you can see, we have fixed it just by setting the cmake runtime output directory, which is very, very nice. Now let's actually go back here. Instead of engine.dll, we're going to call this codoxel.dll. Success. Let's go. But the one problem is that we still have that weird exit code 1 for some reason. But at least right now it seems to be succeeding in actually loading that engine DLL thing. Well, actually say codoxel.dll, right? Alright, so now we're also calling engine init, maybe? Well, we should also check possibly if that's correct. If not engine init, then essentially fprintf couldn't load engine init function. And let's see what's gonna happen. Oh well, it couldn't load it. Interesting. So maybe I gotta do something about that. Let's see. Engine.c and we have engine.h. Okay. Maybe I need to like add extern or something like that. Not sure. Let's try this out. But well, of course I gotta install the engine again. Right, well, basically all. So it still couldn't load engine in its function. Interesting. Okay, let me actually search a bit more about DLLs. So, how to make a CDLL? I think I missed some detail. Let's see. Yeah, maybe that's Dickel spec stuff. I guess so, right? Maybe. Let's try this out. Okay, let's try that out. So engine.c, we don't need this guy maybe. But in engine.h, we're gonna essentially say decal spec DLL export, and let's hope that actually works. Maybe that's all we need. There you go. There you go. It works. Lovely. All right. So hello world. So basically, when you add this decal spec DLL export, you actually expose this function for other executables and DLLs to load it basically. So now we have actually initializing the engine DLL from our launcher. Pretty cool without actually linking hard to it. We're loading it at runtime essentially, which is very nice. Okay, pretty cool. Pretty cool. Now I'm just gonna try to maybe make this work on Linux, but I can't test it right now. So I'm just gonna try to do it, and hopefully I don't get any error. If I remember. Well, if diff Linux and if. Okay, and I'm basically gonna include the DL FCN, I believe. .h is it? DLFCN is it? Let's see. Someone who have Linux need to test this out. Is there someone who have Linux currently that can test this, by the way? Right now? The DLFCN.h header defines at least the following macros for use in construction for DL open mode argument. Okay, so it's pretty much this way. Include DLFCN, nice. So I'm just gonna put this guy here. And now this is if def Windows, well, Win32 like this. Sadly, I'm using Windows. Yeah, I see. Nice. Alrighty. Well, if not engine init, and if. Actually, it's not just about Linux. In fact, anything other than Windows, even Mac OS, etc. So, yeah, I'm just gonna say else. So, if def Win32, else do this. Pretty much. So if it's Win32, we're gonna use Windows.h. If it is anything else, like any Unix machine, like Android, macOS, whatever, we're gonna use DLFCN. And for that, we're gonna actually say else. And if basically. So let's see what we're gonna do now. So if I remember well, it's basically void. So I'm just gonna wing this up, and hopefully it works when someone tests it on Linux. Void library is equal to DL open and DL open, and it's basically gonna be Codoxel.so, I believe. And here I'm gonna go with RTLD, either lazy or now. I'm gonna go with lazy. It's fine. And then RTLD local. Hopefully that's right. And what else? And yeah, let's see what else. Now let's actually test this out. So if not library, well, in fact, I also want to quit, by the way. Same thing here. If that happens, I want to quit. And yeah, that's pretty much it. So if not library, in fact, I mean, handle is just void at the end of the day, right? Yeah, it is. Well, that's interesting. But anyways, so if not library, and then we're just gonna do this. And here, of course, couldn't load Codoxel.so. Now, honestly, instead of doing this, I believe we could use a function called perr for Unix machines. Perr instead of printf. I think so. I'm just trying to find an example because I don't have. This is using ferr. Because my IDE is not helping since I'm on Windows. There you go, void perr const char string. Okay, so instead of fprintf, I could just say, but honestly, I still want, well, yeah, it's fine. Let's just say perr. Alright, perr std, I don't need this anymore. And this would essentially say couldn't load Codoxel.so, and it would also tell why, the reason why, because it would take that from errno basically. So instead of checking errno myself and including etc., this would do all of that for me. So that's nice. Alright, what else? Now let's actually say this. It's a very similar. Though we're gonna be saying engine init. Instead of get proc add addr, it's gonna be dl sym library. I think it's pretty much the same signature, isn't it? Let me make sure that is the case. Yeah, handle and then the symbol. Nice. So that's pretty much it for that one. And since we're using RTLD lazy, we should make sure that it is valid. Otherwise, if you used RTLD now, you don't have to. It would just, I guess so. Maybe not. I don't know. Anyway, engine init. If not engine init, then printf std error couldn't load engine init function. Return exit failure. And now, of course, we're just gonna. Well, there you go. I've just done my best to actually do the code. If anyone have Linux, they could test it when this is published onto GitHub. So yeah. Or if I set up my Ubuntu subsystem. But anyways. Alright, so that's pretty much it. Lovely. So now I think we're done with the launcher. Now let's actually go back to the DLL. It's to the engine now, I believe. Now we could work on the engine. The engine. Type def void pfn engine init decal spec DLL export. I'm not sure if this actually changes between platforms. I'm not sure if that's the case, but anyway. Alright, so engine.c. So now let's just make sure everything is still working just fine. Lovely. Amazing. Okay, so now let's actually start the real deal. So include sdl.h. And the nice thing about SDL is that I don't even need the standard library anymore. Well, at least mostly. And I'm gonna show you why in a second. Voc.h glm and include engine.h. Pretty cool. Okay, so right now let's actually go ahead and say SDL init. And SDL init everything. And let's actually try this out. Okay, pretty cool, lovely. Alright, what else? SDL init everything. Now we gotta actually check for errors here. Now here's what I don't exactly know. Should we, well, yeah, I'm just gonna quit. I'm just gonna exit if something like this happens. So if SDL init everything is equal to, well, yeah, if that's the case, then we're just gonna say if printf cd error, the format is couldn't initialize SDL. Or in fact, instead of doing this, let's just say SDL get error. And well, you gotta make sure, this is why warnings is so good. Format string is not a string literal, potentially insecure. And this is indeed insecure because you should never ever pass a runtime string as a format to fprintf or whatever. You should always use a string literal for formats. So yeah, that's that. And the new line. And then we're gonna basically, I guess, return. Or in fact, exit. Let's just go with exit. -1. Is there like SDL exit? I'm not exactly sure. Well, it doesn't seem like. So yeah, exit and the code, which is gonna be exit failure maybe. Yeah, pretty cool, lovely. So that's basically it for that one. And I'm also honestly gonna put this in an SDL error function, or well, error SDL. And for that, we're gonna basically do this. Fprintf SDL get error, and then we're gonna exit. Well, fatal SDL, I guess. All right, SDL. So instead of doing this now, I could just say this. Fatal SDL. Now what else? What else? Let's make sure this actually works. Declare static. Yeah, I want it static. Could be declared with attribute. Oh yeah. This is why it's good to have all errors, all warnings turned on. And let's go. And there you go. Seems to be working fine. Nice. Now what's next? Let's actually load the Vulkan library, and how you do it with SDL init Vulkan. Did you guys understand what I've done so far? It's pretty crazy stuff, and in fact a lot of these things is my first time doing it. Well, I'm talking about the library stuff, like DLL stuff, etc. But anyways, SDL Vulkan Lloyd library. Actually, yeah, pretty much. And here I'm just gonna pass in null. This is basically if you want to pass in a custom library name for Vulkan, but I'm not gonna do that. I'm just gonna go with the default. Basically, I'm saying to SDL, I'll let figuring out the name of the Vulkan library to you. I don't care. So if SDL Vulkan Lloyd library, I guess this actually returns SDL. Hold on. Returns 0 on success. Okay, nice. So here I'm just gonna say fatal SDL and use of undeclared identifier because your explanation makes it easy to follow and understand. That's very nice, lovely. SDL vulkan.h, nice. And that's basically it. Now it should initialize SDL with everything, including the audio subsystem, video, gamepad, whatever, you name it. So that's why I very much love SDL. And also we're gonna be using its other libraries like SDL image, SDL I believe audio. I'm not sure about SDL mixer, but we'll see. SDL net, I don't recommend that because they're actually reworking it like from scratch in SDL3. And there's also SDL font, I believe, which I think is fine, though I'm not sure. Never really tried that one. But we're gonna see later on how it's gonna go. So function engine init could be declared with attribute no return. Okay. Oh, what is the problem? Zero on success. Command executed now and failed. What if I actually don't do this? No, it's still a problem. Interesting. So what's happening exactly here? SCD error, SDL. Hold on. Oh, what? 0 on success. That doesn't make any sense, does it? Oh my god, why have this fatal SDL here? Like, bro, what? Why in the world? Yeah, I just had this here. But honestly, I need to start using debug, but whatever, who cares? So this should work now. Oh my god, what? Should not return. Oh, I see. Oh, so I don't need actually no return. What? Well, I'm not really. Well, return, I guess, like this, maybe? Okay, there you go. So now it actually works. Lovely. So, pretty cool. Now let's actually get the proc ADDR. So const, well, actually, we're gonna say, let's see, vacay get instance proc ADDR. Now we're starting the vulkan stuff. Is equal to SDL vulkan. Get vacay instance proc ADDR. And of course, we're gonna actually do this. pfn vacay get instance proc ADDR. And let's go. Now what this would do basically, well, Lloyd library would do something similar to what we have done ourselves manually in our launcher. It would call Lloyd library or DL open, etc. And this would actually go ahead and fetch a function from the actual vulkan loader DLL that is in your system, which is called vacay get instance proc ADDR. Now this is supposed to be the entry point, just like here we have our engine DLL have the entry point, which is engine init. The vulkan library have the entry point called vacay get instance proc ADDR, and this function you use it to actually fetch other functions, but in a cross-platform way. So that is very nice. All right, so you don't have to every time use DL SYM or whichever, which is pretty nice. Okay, so let's make sure this is all good. I'm just gonna guess SDL assert maybe, or well, let's just say if not vacay get instance proc ADDR, then fail SDL. There you go. Pretty cool. Lovely. So now let's try to actually initialize Vulk. Initialize custom. Now the thing is, you can go ahead and link statically or link directly to the Vulkan loader in your system. But the problem with that is, let's see, you cannot gracefully handle the error or the case when the loader doesn't exist in the system. So it would just show like a DLL error, for example, like this. You probably have seen this before. Let me see. Yeah, something like this. The program can't start because vulkan.dll -1.dll is missing from your computer. Try to install a program to fix this problem. That is basically it. Your program won't even have the chance to run. But when you use, when you use the dynamic and runtime, when you like link to your library at runtime using Lloyd library or DL open, you actually have the chance to react to the error. For example, here we're reacting to the error by just logging an error essentially and returning exit failure in that case. In this case though, we could do something more cooler. So Vulk initialize custom. Yeah, so here also I'm just saying fatal SDL. Although honestly we could use show simple box or show, hold on, message box. And then I could even use a message box to actually tell the user that. So I'm gonna doodle with that. Well, it's getting some message box data. Actually, I'm gonna use show simple message box, and here you give it the flags. And the flags are message box error, and the title is, well, I guess SDL error. And then here the message would be SDL get error, and here the window is gonna be null. We don't want to attach our message box to any window. Okay. Vulk initialize custom. Now here we're gonna pass in that vkg instance proc ADR that we have fetched from the Vulk library from using SDL, and that's pretty much it, I believe. And after this, I could actually go ahead and get the Vulkan library's version, for example. So printf, let's see, D, and D. Let me zoom in a bit. Okay. And let's say Vulkan. Well, now I could use the global Vulkan functions after using Vulk initialize. So vk get version, I believe. Actually enumerate version. Instance version. There you go. So let's see. If less than 0, then I'm basically gonna say fatal. Actually, I don't really need to say fatal in this case. It doesn't matter. But basically, if this is actually vk success, then we're just gonna print the Vulkan version. And how are we gonna deal with that? vk API version major. Well, in fact, this could give you the version, I believe. Right. And the version in this case would be, now honestly I'm gonna type def some types already. Oh well, type def, oopsies. Oh, actually SDL already does that to some extent. So yeah, I could just use, instead of this, I could just use, well, uint32, just like that. Okay, cool. And then here I could say Vulkan version. And that's basically it. Now I could use that here. Instead of major, I'm gonna go with minor. Hello, Marty Flowers. How's it going? Marty Flowers. Okay. By the way, I have set up that thing that we were talking about. That was crazy. Patch. Took me some time to set up all the DLL setup, etc. But we have done it. As you can see, decal spec DLL export, and here's the, where is it? Where's that stupid thing? Hold on. The launcher. Let's see. Where's the launcher? Here. No, not this one. This one. Okay. Here's the launcher. It basically goes ahead and it actually opens up the DLL. All right. The hot code reload. That is amazing. You didn't even know it was a thing. You work fast. Well, the hot code reload is still not done yet. I'm just setting up the framework first of all. And yeah, pretty much. But yeah, that is coming very soon. But I still didn't even actually load in the game itself. But that should be pretty trivial, I guess. I would guess. We'll see. All right. So what should I do now? Alrighty. Well, I'm gonna say Vulkan API. And what are you even talking about? What do you mean by 1 point? Oh, I see what's the problem here. This should be minor. I was like, bro, do I really have Vulkan 1.1? Are you kidding me? And there you go. As you can see right now, we have successfully loaded our engine from the launcher, and then the engine goes ahead and it loads Vulkan library. And there you go, Vulkan API 1.3.241. Let's go. I'm still testing the humble hello world triangle. That's gonna be a long way. All right, found the exe would crash on Linux and rewind if I try to reset the Windows too much. Oh, by the way, are you on Linux? Can you test this up? Because I didn't really test the launcher. Where's launcher? Can you test this up? I still didn't test the Linux launcher. Oh well, I actually have to first of all publish this into GitHub. Did I have the license yet? I still didn't do the license. Hold on a second. Let's set up this for Git real quick. And this is actually a good place to really go ahead and just commit everything. Hold on a second. What is this? It's inside clangd.cache. Okay, let me ignore that. So let's set up this into GitHub first of all. Actually, .cache it's called basically. And let's see what we have now. What? No idea. How can I unstage this stuff? And also, I'd like to ignore one other thing, which is VS Code. In fact, I believe anything that is, hold on. If I do this and then I do something like this, so basically anything that is hidden, no. Yep, I would guess that may work. Nice. So I don't need this now. So anything that starts with the dot, it wouldn't get staged or whatever. Okay, pretty cool. So And yeah, that's pretty much it. Now let's just go ahead, message, and let's say Vulkan API version. Actually, let's say second stream. Okay, second stream. I guess. Okay, cool. Commit. Well, I still didn't set up my GitHub. Oh my god. I guess you can do it here if I remember. Turn on setting. Hold on a second. I remember I've done it from somewhere. Sign in with GitHub. Let's go. Okay. What about now? I still have to configure that. Okay. Okay, let's see how you do that. User.name, etc., etc. So let's see how do you do that. Git configure. Okay, this is good to also show you how you can set up your Git. I guess git config -- global user.name. Yeah, user.name, and then you say what is your username. I believe it's Codotaku Yeti. Let me make sure that is the case. Hold on a second. GitHub.com. And it is, well, hold on, let me go for example here. Okay, yeah, it is codes. It's actually Codotaku Yeti. Okay, it's actually Codotaku Yeti, my old channel name. And yeah, now git config -- global user.email. And let's see, I'm going to type in my email there. And yeah, now hopefully this would work now. Commit, and let's go. Now publish. Let's sign in with GitHub. Open. Let me make sure I don't have this already. Let me make sure oh, I guess I do. It's probably some, yeah. I see. So let's actually remove this first. Hold on. How can I remove it? Settings. Let me confirm. There you go. So right now it's actually successfully deleted, and hopefully right now I could go ahead and publish. Hold on, let me grab in the okay, nice. So now it's actually published to GitHub public repo. Hopefully that would be fine. Come on, you just signed in, really? What? Oh, successfully published. Yes. Oh, I forgot about the license. Oh my god. Well, help people interested. I also forgot about the readme. What is classic? What exactly is classic? You mean forgetting about the license? Or something else? Alright, let's actually get yeah, let me go back to one of my projects here. Let's go to GitHub and then just copy in the license and the and I don't care about the readme for now. Codotaku or well, hold on, no. For example, this maybe license. No, I meant Chrome asking you login again. Oh, I see. Alrighty, this should be fine. MIT license, let's go. And yeah, commit, sync. All right, pretty cool. Let's go. It's published. Now, hopefully, Marty, you can just have no problem with it when it comes to setup. Let me know if you found any problem with setting it up. That would be nice. CPM add package. Alright, let me know if it actually succeeded. If it succeeded from the first try, I'm gonna be very I don't know. Anyways, it just never works at the first try, but let's see. Okay. By the way, make sure to use Clang. Make sure it is using Clang. Make sure CMake is using Clang, because that's the compiler I'm using. And to be exact though, Clang dash version, Clang 16.0.6, and then CMake, same thing, 3.27.4. Is VS Code CMake Tools extension good? I mean, it's fine, it works. Here you can basically choose your kit, which is basically the compiler, and then here you could essentially pick up the target that you want to build. In my case, I'm just saying all. So we'd go ahead and install the engine library, the engine DLL, and then we'd also go ahead and basically set up my Codoxel launcher. Yeah, it's pretty good. So yeah. Alright, let's go back to work while Marty is trying to set it up on Linux. Okay, so engine init. Engine. Alright, pretty lovely. Let's go. Alrighty. I just used the sh files for my project, so I'm limited to what I can do. Well, Visual Studio eats my PC a lot. I think VS Code would work for you. I think VS Code would work. So yeah. Alright, the nice thing about CMake is that it set up all the crazy stuff for you. For example, IntelliSense. For example, it generates compile commands for you. So here you go, compile commands.json, and this file is being used by ClangD to actually give me very good IntelliSense and also very good warnings, etc. And also the C++ stuff. You know, you got the point. It took me some time to actually figure out the best setup for me when it comes to CMake and VS Code and all that crazy stuff. It's very wild. But yeah. Alright, so let's go ahead and I believe let's create the window. Alright, nice. So in fact, let's see, STL init. Well, let's actually, honestly, let's go with the instance first, maybe. I'm not sure. Well, let's go with that. Why not? Okay, vacate create instance info, is it? Huh? Oh, I think I need to include Vulkan. And though I gotta make sure that this is actually using my Vulkan headers dependency. As you can see, it's not dependent on the Vulkan SDK. It's actually dependent on Vulkan headers that I pulled using CPM. So whoever wants to compile this hopefully doesn't need the Vulkan SDK, which is pretty cool. It makes the project self-contained. Anyways, so I always forget what I was doing. Okay, vacate instance create info, and so this is gonna be like const. But honestly, before doing this, I'd like to make the renderer would be its own thing, because that's gonna be massive with Vulkan. So let's see, src engine.c, and then we're gonna have like new file, render.c, and include render.h, and there you go. Pretty cool. Render.h and render.c. And now here, everything that I have to deal with Vulkan, like this stuff right here, would be gone to the renderer side, not SDL init though. Okay, let's see, engine init. If SDL Vulkan Lloyd library, no. Okay, so let's actually remove this from here. Oh, hold on, I forgot about this guy. And let's put it on our renderer. So render.h, well, I guess void maybe, for now at least. Render init. Though actually it's basically gonna take a struct, right? So type def struct, right? Render, let's go. And this would actually contain, well, nothing for now, I guess. So render here, renderer, and I believe that's basically it for now. Though we're also gonna have renderer create info, just like how Vulkan does it. So render create info, create info. Alrighty. I don't like parameters anymore. I always just use structs because they're just much more superior when it comes to API design. But anyways, and that's pretty much it, I believe. And then void render, actually not init. Let's go with the how Vulkan does it. Render create. Sorry, had a little side quest. Updated and seems XDG configuration is broken. Oh my god. You are on the Linux land. That makes sense. Render destroy. First change, I need to make it requires 3.27.4, but I have 3.27.2. Just select whichever version. I just selected the version that I have, but tune it down to whatever version you have or even lower, and let me know. I just set it to the version that I have and call it a day. So render, and there you go. That's pretty much it, I believe. Render destroy. Actually, it should be, hold on, it should be like this, and maybe this should be like this, right? Yeah, I think so. Actually, is it? Hold on. Not really, not sure. We'll see. We'll see. Render destroy, and then let's go now to implement this. So void render init. Well, I don't want to lose my work here, so let's just copy this now. There you go. And of course, pragma once. Oh, I forgot about pragma once here again. Pragma once. And then here we're gonna say include render.h. And there you go. Pretty cool. So it used parameter renderer. Nice. Okay. So now we're just gonna have this way, and then this way. Lovely. And there you go. Now is SDL vulkan. Well, we also require SDL, right? SDL3. Though honestly, we don't need to do this here, really. Yeah. Honestly, what the renderer really need is just the pfn vkg instance proc addr. But you know what? We're also gonna create the windows here, like the actual window in the renderer itself. So anyway, never mind. Let's just leave it like this. So okay, include SDL vulkan.h and fatal SDL. Now we don't have that here, so honestly I'm going to make some sort of shared util thing. Well, I'm just gonna create a new folder. I think I'm gonna call it include, and then I'm gonna call this maybe utils.h, possibly. I think so. And then basically we're gonna have this stuff inline, I believe. Fatal SDL. And oh yeah. And then basically include scdio.h. And in fact, I don't really need scdio.h, as I said before. In fact, I could use sdl log. But you're gonna see in a second what I mean by that. File not found. Okay, makes sense. Let's go to our CMake and target include directories. Well, at least for now, engine. Actually, do I really want to share upon all? No. My bad. Let's just keep the utils on the engine side only, really. So yeah, let's go ahead and do that. Where's utils? I'm not sure what I was thinking when I did this. So let's just do it here and delete this guy. Okay, and this should work already anyways. So utils.h. And yeah, now instead of fprintf, we're gonna use sdl log error, and then here instead of std error, we're gonna say sdl log category error. Well, actually category application, I believe, and that's pretty much it. SDL fmt and the SDL get error. And we're also showing a simple message box. No new line at the end of the file, and there you go. Now that should be good to go, I believe. So here, actually, well, render, right? Yeah, okay. Include utils. And there you go. Now use of undeclared identifier vkg instance proc addr. Oh. Since we gotta include, yeah, I see what's happening here. So go back to the engine.c, I believe. And in fact, we're gonna need a lot of this. For example, SDL3, well, not SDL3, but SDL vulkan, CGLM, Volk. Yeah, you got vulkan, and SDL Volk. That's a lot of crazy stuff. Yeah, in fact, it's pretty much all of them, really. Yeah. Hold on. Go back. And yeah, we're basically gonna copy this guy, but we don't need the Vulkan stuff anymore. So yeah, this could go out from here, but let me first of all copy this, and let's remove this. Let's actually include utils.h for fatal SDL, and other than that, we gonna go to engine.h or what? Yeah, render.c, and we're gonna go here, boom, and SDL Vulkan. Now we don't need this anymore, and yeah, I believe that's it. Come on. In use parameter renderer. Yeah, it is in use right now. Marty, did that work for you, or you're still battling with that thing? Render create. Decal spec attributes are not enabled. Use -f decal spec or -fms extensions to enable support. Are you sure you're using Clang? Are you sure you're using Clang? Yeah, I was suspecting that maybe wouldn't be cross-platform. Hold on. How you do it? Do nothing and hope for the what? This is very interesting. Marty, are you using Clang? All right, I think. Let's see. Can you try, Marty? Can you try to, replace that decal spec DLL export thing there with this guy and see if it works for you? Attribute visibility default. Hold on, let me copy it over. Let me know if that works. What decal spec DLL export doesn't work on Linux? Yeah, it seems like I mean, I do remember that there was all sorts of magic to actually, all sorts of macros to make it work on depending on the compiler, etc. But I never really understood it very well, and now I see why they're doing it. But yeah. Honestly, let me try to install the WSL2 because I really need to test this stuff, honestly. So let's go ahead maybe to terminal, and hopefully it wouldn't take too long. WSL install, I believe. Yes. And let's go. Though I'm not sure how to make VS Code works with WSL, so I can get some sweet intelligence. Well, hold on a second. VS Code WSL. I made the change and now it builds. Really? And does it actually run? And by the way, make sure you basically have to build all targets. Basically, you have to first of all use the install target to actually install the DLL, the engine DLL, and then you have to execute the Codoxel launcher, of course, to build and run that target. And let me know. And since that's the case, in fact, let's go to our engine.h. And basically what I'm going to say is, I believe, if defined Linux, or well, in fact, let's go with Win32, I believe. Then I'm going to go with define DLL export if def time as always in def, and define DLL export, and let's just hope this actually works. And yeah, that's it for now, I guess. And instead of decal spec, I'm just gonna use DLL export. Macro magic. Though you may be able to even get away with it without any of them. I'm not sure. I need to test this, honestly. Alright, Ubuntu has installed, but oh my god, I have to reboot my system to be able to use it. No, thank you. I can't reboot right now, so I guess maybe next stream I'll have that. But for now, we cannot. Macros for the win. Alright, so can we go back to engine.c now? What was the problem, by the way, that we were trying to solve? Macro is a reserved identifier. What are you even talking about? Oh yeah, I need that stupid. Alright, gotcha, makes sense. Well. We gotta do this. In fact, do I need to do that? Yes, I do. And in fact, let me put all my stuff here. Hold on. Like CGLM, I also need that always. Everywhere, basically. Because why not? So... and pragmaClang diagnostics pop. And that should do the trick. There you go. Cool. And in used function. Alright. Lovely. So now I don't need to include SDL. and GLM anymore. Alrighty. So now, what we're gonna do? Well, let's actually right now try to basically say vacate application info. And what is going on here? Oh, I see. Dot application. Well, I don't care about all of that stuff. I only care about S type, which is gonna be this. And then we're gonna have API version, which is gonna be vacate error xtg runtime dir is invalid or not set in the environment. Vulkan API 1.3.261. So it works, right? I mean, you're getting Vulkan API, which is that the message that got printed? Because if it is, then it did work for you, which is nice. I renamed the lib and it seems to run. Oh, which library? Oh, did I actually? Hold on. Which library? Rename the lib. But that is nice that it actually works. I basically just wrote that and hoped that it would work. Which is pretty nice. Vacate API version. Now, not sure which one I'm gonna use. I'm just gonna go with the 1.3, but yeah, 1.3. Although, if I want to make it work currently on Mac OS, I'd probably want to go with Vulkan 1.2, but I don't care about Mac OS, honestly, for now at least. But it can catch up, like Molten Vacay is catching up on. They're still actually right now still working on version 1.2, and Android is still far behind. In fact, if I show you here, Android Vulkan stats, something like that, distribution, right? There you go. So 15% of Android devices doesn't have Vulkan at all. So you'd have to use like OpenGL ES for that. And 8% you have support for Vulkan 1.0, like the first Vulkan version. And then there is 77% have support of Vulkan 1.1. So yeah. So if you want to basically make it work on Vulkan on Android, then you'd probably at least want to go with Vulkan 1.1. On macOS, you'd like to go with 1.2. And honestly, I don't care about them. That's what I said when I talked about I don't want to limit myself to these platforms because they're just trash to work with. They're always backwards and they hold back a lot of performance and all sorts of craziness. But anyways, all right, unused variable, vacate application info. Now what else? We gotta go with instance create info now. Is that what they mean by Vulkan is cross-platform, Kappa? Well, it's not the problem of Vulkan, really. Vulkan is just an API, but it's the problem of those platforms. macOS is trying to force everyone to use their own API, Metal API. You know, they're trying to force everyone on their platform to use this. Which actually is quite nice in some sense, because since Metal is only constrained to Apple hardware, you don't have all that crazy compatibility stuff that you have to care about, and that's why Vulkan is kind of complex and verbose. A lot of it comes back to the fact that you want to support as much hardware as possible. But for Metal, they have a much nicer API, a much more ergonomic API because they don't care. It's like Metal is only for their own thing, right? Their specialized API, which is nice for people that wants to develop for Apple and not nice for everyone else. But yeah, I respect their decision to basically just, because I think honestly I don't care about cross-platform anymore. I think you probably better off go ahead and program using the native API of that platform. For example, if you're going with Android, let's say, you gotta go with Android Studio, use Java, etc. with the NDK, of course, but you got the point. Spurvy doesn't work on macOS, right? Well, they actually go ahead and translate it pretty much. It's like the thing is, Metal, like macOS, like Vulkan wouldn't work on macOS, but there's Molten VK. There's this thing. Well, in fact, is it this? Yeah. Molten VK is a Vulkan portability implementation. It layers a subset of the high-performance industry standard Vulkan graphics and compute API over Apple's Metal graphics framework, enabling Vulkan applications to run on macOS, iOS, and tvOS. Alrighty. So, as you can see, it only supports Vulkan 1.2 right now, but only not fully, and it's not fully confirmed yet, though it's probably gonna be soon, I guess. But anyways, all right. So basically, what's happening here is that the thing is, Vulkan is just an API. It's not really like a library or an implementation. Who really actually implements the Vulkan? Anyone can really implement Vulkan, but mostly it's actual drivers. You know, the drivers like NVIDIA driver, AMD driver, Intel driver, etc. is the one that implements the Vulkan API. And basically, when you actually load the Vulkan, well, in fact, I'm loading the loader, but just for the sake of simplicity, let's say I'm loading the driver directly, just for the sake of simplicity. You basically gotta load the driver's implementation that is inside your system. That is why we're using actual runtime loading of the library. So since that's the case, what happened here is that Molten VK is making their own implementation in Mac OS and Apple hardware, Apple platforms, right? They're making their own implementation, and then instead of actually, you load the Vulkan library from a driver, you actually load Molten VK implementation, which actually uses Metal at the end of the day, the Metal API. It basically translates those Vulkan calls to Metal, to the Metal API, which Apple uses. So it's pretty crazy, but there you go. That's hopefully that makes sense. It took me some long time to figure all this out, but yeah, it is a translation layer. Yeah, kind of. Although it's not one-to-one translation, but you got the point. I see. Thank you for the information. It's fine. You're welcome. So like DXVK in Linux. Yep, exactly. From direct, I guess from Vulkan to DirectX, maybe. Actually, from DirectX to VK. Yeah, from DirectX to Vulkan. Yeah, alright, never mind. So now here, let's actually go with instance create info. Well, in fact, I'm going to do this. I'm just gonna scope this up. Yeah, for running Windows games. I see, makes sense. Righty, and here I'm just gonna say info or whatever. And let's see. Oh my god, C++. Okay. P application info. What else? Enabled extension count or flags or what? Yeah, we gotta actually tell SDL to tell us what are the required extensions. So, alright, so if SDL, well, let's see. Vulkan, get instance extensions, And SDL actually follows the way that Vulkan does it, which basically you have to get the count and then call basically null ptr here. Well, C++. All right, null, and then so basically this gives me SDL false or SDL true. Okay, so if not, then I'm basically gonna say fatal SDL. Now of course here I'm gonna have like a UN32 count. Notice I'm actually using not UN32T but UN32, which is actually defined by SDL. As I said, SDL really helps with being cross-platform in a lot of ways. It gives you its own login stuff, it gives you its own, I don't know, it's like just a lot of cool stuff. Anyways, let's see. So now we got the count of the extensions. What's next? Now we basically gotta allocate some memory for it. And how are we gonna deal with that? Well, hold on a second. What is this? It needs, hold on. It needs extension names. Oh yeah, an array, right. Okay, hold on, go back. Const char, something like that. Okay, so extensions is equal to malloc. Well, we could use SDL malloc. Size. The size would be count times size of char. Actually not char, but pointer char. Right, pointer to a char. And yeah, that's pretty much it. And used variable extensions. Okay, cool. Now next up, yeah, alright. Now next up we're just gonna call this again. And this time we're still gonna pass it the count, but we're also gonna pass it right now the allocated memory. So yeah. Oh, what? Yeah, I think that's what? I'm not sure. SDL malloc. Yeah, I think it should be fine like this. I'm not sure. We'll see. All right, so what else now? Now we could pass it up. So enabled extension count is equal to, well, essentially count, and then the extension. Oopsies, oopsie doopsie. I'm gonna say extensions here, and that's pretty much it. What in the world is happening here? Oh, I see. Never mind. Okay. Now this would be extensions count, honestly. Extensions count. And there you go. Pretty cool. And yep. What else now? Let's just call if vacate create instance. In fact, you know what? Say fatal vacate. And now we're just going to say vacate create instance. And here we're going to say, in fact, not fatal vacate, but essentially check vacate, right? And vacate create instance, what we're going to do here. Why it's not giving me IntelliSense as well? Let's first of all, I guess, do this maybe. Check vacate, and it's basically gonna take in result, and if result is less than 0, Actually, not as the alligator. Not that. We're gonna go with well. Result. Now it is, by the way, a mistake of doing this not equal to Vika's success, because Vulkan results aren't just success or error, but it's also warnings. So basically anything that is above 0 is actually a warning. If it is 0, then it is a success. If it is less than 0, then it is an error. So it's important to do something like this. Yeah, you could just say 0, but I think this is more readable anyway. Okay, no previous prototype. Well, just say static please. And of course we're also gonna make sure to exit one. Well, exits failure. Though I'm gonna make sure maybe to possibly debug this. Let's see. I remember that SDL also gives me such a thing, but I don't remember. It's trap or something like that. Let's see. Not that. I don't remember the function. There was a pretty cool function. I don't remember it, but anyways. Oh, maybe break. Hold on. As such, the assertion facility. Okay, I think it's basically right now trigger breakpoint, maybe, I don't know. Yeah, it is debug break, as you can see. So this is basically cross-platform, so I don't have to do the macro magic myself. But in fact, I still have to make sure that it's debug. I could do the same thing with the other guys. If result less than Vegas success. And where is that other guy? Hold on. Utils.h, right? Fatal SDL. Before exiting, we're gonna deal a breakpoint. Righty. We're probably also gonna show a message box too. Why not? How are we gonna deal with that? Oh my god. I'm exiting before triggering the breakpoint. Interesting. Vulkan error. Instead of SDL get error though, well, interesting. Oh well, I don't want to deal with that now. I gotta basically allocate some format string or whatever. Anyways, so SDL trigger breakpoint, nice. But hold on, let me make sure to do it before exit. Oh, Marty, did you actually get it to work on Linux? Oh, yeah, you did, I think, right? I feel like I was waiting for something. But anyway, vacate create instance. Alright, so now let's just pass in the info. Const allocation callbacks. No. And here you get the instance essentially. And well, you just say vacate instance. And that's pretty much it. Now this should actually work out. And then we basically say vulk Lloyd instance only instance. And there you go. Now, here where you actually need the Vulkan SDK to actually get some cool tools like vacate config. But for someone who just wants to compile the engine, he doesn't need that. Just to debug the engine, where he actually needs something like that if he wants to. So validation, there is API dump, and oh my god, it's so my eyes. Anyways, so let's go with validation for now, I think, and let's try this out. And there's no validation errors, I believe. What about API dump? What? No way. What's happening? Why it doesn't show? Is it that stupid problem that I had before? Hold on a second. Is the log? Hold on. Hopefully this is not the error. Oh, I think I know what's happening. I think so. Yeah. Oh well. Render init. But before we could do that, we have to include render. And then we could say render init. Bro, come on, what? Oh, render create. Makes sense. And here the create info, it would basically be and just like that. Now I'm just gonna say, well, render. That's pretty much it. So, okay, let's try this out. Empty struct. WC++ compatibility. I don't care. That is the engine. Okay. Empty struct is a GNU extension. Well, I just want to debug this, bro. Come on. Well, let's just do something. I don't know. Well, in fact, yeah, okay, fine. Vacate instance. instance. Don't think. All right, never mind. And for the render, we're gonna go with, well, what I'm doing. In fact, I wanted to do this here. And known type name vk instance. I'm just gonna forward declare this. Maybe. Or we could just include vulkan here, in fact. But let's just do this. Okay, type def. I guess, or honestly, never mind. Let's just go ahead to render.c and let's grab these guys. Well, honestly, let's just grab all of these to here for now. To where? To render.h, I think. And there you go. Oh, what I'm doing. Not that one. Render.c, where is it? There you go. And yeah. Too much files. Const char, let's say, is equal to, well, can you build now? No new line. It doesn't end. Dot in used. Come on, I just want to test this stupid thing. Render create in the find symbol. Oh well, that is interesting. And I know why. Because we didn't include it yet. Engine slash src slash engine, well, render.c. And now unused parameter renderer. Come on. Instance is equal to instance. Unused parameter create info. What? Bruh. Finally. And there you go. Here you go. Now, if we didn't have this API dump thing working, it wouldn't actually work. As you, well, it's given me right now. Oh, I see. It's giving me validation now. So it tells me that I forgot S-type here. Instance create info. And let's go. Oh, this is probably just info which I don't care about. Alright, so now we have no validation problems, which is nice. If we go back to API dump, as you can see, here is the extension that is being passed. Nice, pretty cool. Alright, so we have created an instance now. Next up, I think we would get essentially a physical device. And how are we going to deal with that? Well, hold on, I need to clear this up for a second. Okay, cool. Now, let's go to render.h. And here we're going to add vk physical device. Okay, cool. Now for physical device, it's gonna be essentially well, vk enumerates physical devices. Oh my, not pfn. Now you're supposed to do something similar to this guy, but I don't care about all the physical devices. I'm just gonna get one physical device. So here's how I'm gonna do it. Physical device. And here I'm just gonna say, oh well, I could just say this, in fact. And same thing with this guy though. Though I have to actually do that every time, so a big no there. So just keep it like that. And then I'm gonna have here vk physical device. And here render physical device is equal to physical device. Well, now we got the physical device too. After, well, vk check. Check vk, cool. Now other than that, we're gonna actually create a device already. So for that, though, hold on a second. I kind of forgot about something here, which is that shouldn't be here. And this guy shouldn't be here either. Should be outside of the scope. So now I could just do this. Nice. Physical device. Great. Now vk queue, well, device queue create info. Alright, so queue count's gotta be 1, queue family index gotta be 0, queue priorities would just be hard-coded 2. So we're just gonna go with F32, I believe, or well, just float, right? And we're gonna say, well, it doesn't matter really. And yeah, I forgot about the S type too. So for the S type, it's gonna be vk structure type, device queue. That's pretty much it. I'd like to have the S type here though. And yeah, now let's go with vk device create info. Well, honestly, I'll just call this queue info, and this I'm gonna call it info. Though honestly, I don't really have to do it this way. Hold on. Here's how I can even simplify this even further. For example, this doesn't even have to be there. It could directly be embedded here. Oopsies. And there you go. Pretty cool, huh? extensions count. Nice. And same thing with this guy. PQ create infos. I could just say this and this and this. Oopsies. And now I don't even need this here. And in fact, I could even go more and essentially do it like this. And yeah. Alrighty. Now same thing here, I guess. Now in fact we could just save vacate check. Oh, check vacate, right? And then here we could say vacate create device. Here you give it the physical device, and then you give it the info, which is this. And then you give it the allocation callbacks, which I'm gonna go with null for now, honestly. And then here you give it the device. And yeah, I could just get off this. In fact, I don't even need to do this now, just do it like that. And then essentially the device is this device. So as you can see, I'm just hard coding a lot of stuff. For example, I didn't check if the physical device is fine. I'm just taking the first one and I don't care. And I'm also hard coding the queue for now. I'm only interested in one queue for now at least. So yeah. Now after this, you just gotta say vulk load device. You give it device. So essentially here I loaded the instance function pointers, and now here I loaded the actual device pointers. Now if you were to actually use the loader directly to link it directly, then what's going to happen is that every time you call a device function, or every time you call any vulkan function, you got to go through the loader, and you know, you got several redirections, at least 2 redirections by the loader. Why? Because you may have multiple physical devices, you may have multiple drivers, so multiple vulkan implementations. And now when you select the when you create a device, you selected a physical device, which means you also selected a driver, right? And a specific implementation. So instead of having to go every time through the loader and then it goes ahead and dispatch you and you have to figure out which driver you're talking about, so it have to dispatch you to the right driver. What you do, you actually load the device pointers, which basically gives you pointers to the driver directly. So whenever you call vulkan functions after that, the device one of course, you have no middleman. You're calling directly through the loader, through the driver, right? Which is nice. Now we could use vulk load device table to basically support multiple devices, but I don't care. I'm only going to be having one device. So yeah, and that's pretty much it for that one, I think. So now we could add that too. Vacate device, render device equal to device, and let's go. Now in fact we got the device ready, hopefully. Now let's see if we have done everything right. Let's see. And as you can see, vacate, well, what's happening here? Vacate get physical device queue family properties. What? I'm not even calling that. Yeah, bro, what the... Hold on, really? I'm only calling create device. Where he got this stuff from? Are you kidding me? Maybe Volk is doing it? Sorry, not Volk, but that Vulkan memory allocator, maybe? I don't know. Weird. Q physical, or maybe some bug. I have no idea. But I'm surely not calling those myself. But anyway, it seems to be fine. So what about validation? Alright, we have some validation errors. Yeah, I always forget about the S-type though. So S-type is equal to vk structure type device create info. And I also forgot about a lot of other things. Which, yeah. So for the extensions, there's also device extensions. So I'm gonna go with one extension, I believe, for now. Later on we may add more. So pp enabled extension names is equal to this. So vk, well, not vk, but well, char, gonna go with swap chain. And there you go. And let's go. Lovely. Pretty cool. Not sure. Anyway, never mind. For now, I'll just keep it like this, I guess. Okay. So Q create info counts. I also forgot about that. Q equal to 1. So as you can see, validation is very important, and now I have no validation errors. Lovely. Right, so that's pretty much it. And by the way, you right now Vocaloid device though, since I have a validation layer enabled, I'm not actually really calling into the driver directly currently. I'm calling into this validation layer. I'm loading the function pointers to this validation layer, which actually goes ahead and calls the driver. So there is a one redirection right now, but if I disable all layers, I'm pretty much going to be loading the functions directly. But anyway. Okay, what else now? Okay, I think I want to probably go ahead and essentially well, let's first of all create that void render destroy, in fact. And for that, we're gonna say okay, let's actually destroy stuff up. How do you do it? Okay, destroy. Let's start with the device now. Oh well, render device, and then null for this one, and then vacate destroy instance. Oopsies. Then render instance null, and let's go. Other than that, what else? Maybe also STL Vulkan in Lloyd library. That's pretty much it. That seems to be good. Render, destroy. Now let's actually include vkmmalloc. Basically, we're gonna set up in the Vulkan memory allocator. Later on, we may replace that with our own implementation, but for now, I don't have that level of knowledge to replace it with something better. So we're gonna go to the library. So let's see if this actually works out. Hold on. In fact, I'd like to go to the documentation. I have to define this VMA implementation thing here. Before including that guy. And what else? Because it's a header only library, I think. And yeah, this is not needed in our case. Though this is actually needed. Oopsies, let's go. So I don't care about static Vulkan functions, I don't care about dynamic too. Right, because I'm gonna be giving it the functions from Vulk. An included file error in C++ standard library usage. What? Now let's try to actually run this, I guess. And error in C++ standard library usage. Interesting. Maybe it's a problem of CMake. Hold on a second, because I remember that I had to maybe do something like, well, maybe CXX basically. Add C++ because the Vulkan memory allocator is written in C++ for whichever reason. Still have that stupid problem. Error in C++ standard library usage. What? Not this. He seems to be using Rust cargo. Interesting one. What? Pulling LVM. What? Are you kidding me? Let's go to Visual Studio Installer. Let me make sure I'm doing this. I mean, I do have C++ stuff, I just don't get it. There you go, desktop development with C++. I guess let me make sure to install this too. Oh my god, 8.34 gigs, like bruh. MSVC is crazy. That's why I wanted to use Zig CC and Zig CPP, but it didn't work with my VS Code. At least I couldn't get it to work on Windows. I don't know. So yeah, let's just try to add Clang tools of MSVC, because sadly we are on Windows. This is gonna take some time. Alrighty. Alright. And then I think I'm gonna switch the tool chain to basically using MSVC's Clang. Because I think it's probably C++. There is maybe like a clash between the installed standard libraries of C++ and the stupid Clang stuff. It's weird. It's pretty crazy. Alright. And at least hopefully that would work. At least that's what I think is the problem is. What about, I mean, I'm not, well, yeah, let's just wait for MSVC's Clang to actually install, basically. And let's see. And for now, I'm just gonna have a break, at least until this installs, so. Alright, back. Let's go. So it seems to be installed now, hopefully, and let's try it out. So I'm just gonna restart Visual Studio Code, and let's see what's gonna happen there. So it should, right now, I should have more options here. I'm just gonna scan for kits, and it's gonna scan. It should find MSVCs. There you go. Seems like. Alright, let's see. There you go. As you can see, we have some other options. There's release, and there's this guy. Weird. GNU CLI for MSVC. AMD 64. Right now, I think I'm using MSVC's Clang, and hopefully it should be good with the standard library. So yeah. I think basically Clang was built with different libs or something. I don't know. Basically incompatible libraries, maybe. Now, moment of truth. Let's see. Subcommand failed. Linking C static library voc.lib. What? Oh, it's still the same problem? Are you kidding me? That is very, very weird. Oh well. Is it like a Mimus VC kind of bug or what the? Okay, well, this is so weird. What about this? Though I think this would use MSVC now, not Clang. So no, I don't think that would work for me since I'm using Clang stuff. CSTD23 is not known to C compiler. MSVC. Yeah, I knew it. So, yeah. Well. No idea what's causing that stupid problem. This probably wouldn't be a problem in Linux. All of these problems is just because we're using Windows. But anyway. Right, so I think, well, let's just maybe forget about vkmmalloc for now, I think, because that's what's really trying to use a C++ compiler at the moment, and it's causing us problems. Yep. And if I add vkma malloc, oh my god, I think I know what's the problem though. Actually, it's probably my problem. I think I know it's that now vkma malloc is actually a cpp file. So you gotta actually include the implementation in a cpp file. Oh my god, I think that's probably the problem. So yeah. Okay, let me see how I can fix this now. Let's say new file, and I guess let's say I don't know, let's say third party, or well, let's say impl.cpp for example. Okay, and define vma implementation here, and of course you gotta include, so don't define vma implementation in a C file, since it needs a C++ compiler. I believe that's probably the problem here, essentially. Yeah, I'm glad I remembered this one. It's kind of tricky to catch. Okay. So now what? VMA implementation, static, dynamic. Yeah, that should probably work now. Okay, now let's just go to CMake and go to here, and we're just gonna say engine/src/impl.cpp. And let's try it out. Yeah, let me add that guy, hold on. Oopsies. Let's actually remove these guys from here. Let's do it here. Let's try this up. Come on. Deprecated, obsolete, preserved for backwards compatibility. What? Are you kidding me? Oh, I think I know it. Yeah, make sure to actually include this stupid thing here. And now let's try it out. Should hopefully work now. Yep, there you go, we fixed it. So the problem was basically that I was actually including a C++ file implementation, or header only implementation in a C file, and that was giving me that weird not so useful error, but there you go. So I just had to add a cpp file and add that there basically. So now I could actually go ahead and create our allocator. And VMA allocator is pretty good at allocating optimally for Vulkan. So yeah, that's what we're using it. So Vulk Lloyd device. After we have created the device and Lloyded it, etc. What we're gonna do right now, in fact, is, well, where is that guy? Hold on. what I'm doing. Let's go here, I believe. Yeah, there you go. And I'm just gonna copy and paste, and let's see what we have here. VMA functions. Now you could use this if you're going with the what is it called again? If you're going with dynamic Vulkan functions, but I'm not going with that. Yes, I'm setting it to 0, basically false. So in fact, I gotta fill all that stuff, okay, manually. So basically, yeah, this, I gotta give it all of these function pointers essentially. So let's go. Well, this is gonna be a chore. Oh well. I just don't want to write a whole script just to do one thing. Actually, I don't need this guy. And I don't need that one. I need get physical device properties is equal to vacate get physical device properties. What else? I need vacate get physical device memory properties is equal to that. And what else? This, no, not that. This is equal to that. What else? Free memory is equal to free memory, and then vacate map memory. Oopsies. Map memory, and then vacate in map memory is equal to vacate in map memory, and then vacate flush map memory ranges, and vacate invalidate equal to vacate invalidate, vacate bind buffer memory, vacate bind buffer memory. These are basically all the functions that are used by VMA. Since I already have loaded them, I'm just passing them over. Bind buffer memory. Bind buffer. I wonder if there's an easier way than doing it like this way. But anyway, bind buffer memory, bind image, right? And get buffer. What else? Now we pretty much have finished with the functions that are really needed. Now we're just gonna pass into the functions that require some specific Vulkan version. And yeah, as you can see, these are well, never mind. And the stuff that needs an extension. But honestly, I'm just gonna pass them over anyways if they're not valid. Like if I don't have that, if I didn't enable that extension, it would just be null anyway. So for now, I'm just gonna pass them. So if later on I decide to enable like one of these extensions, I don't have to go back to this basically. So vacate get buffer memory requirements 2khr. And then that's one there. So this basically needs VMA Vulkan version greater than this, and then dedicated allocation extension. Anyways, bind buffer memory to KHR. There you go. And then this basically needs Vulkan version 1.3 or above, which we do have. And then finally, image memory requirements. And yeah, hopefully I didn't make any mistake or miss something there. So this should work out just fine, hopefully. I don't need any of this. And what else? Okay. Now I'm just gonna pass in the Vulkan API version, which is gonna be VK API version 1.3. And by the way, did I actually pass in? Yeah, I did. Nice. Now physical device. Okay, cool. What else? Now the device to the instance, and p Vulkan functions is equal to Vulkan VMA Vulkan functions, and then I could just simply just say this. Remove this from existence and put it here, and there you go. Lovely. Now I don't need this anymore. And yeah, VMA allocator, create allocator. Here just gonna say vacay, check vacay. And yuppie, lovely. And that's pretty much it. I think that should do the trick. Now other than that, we can go to renderer and add a VMA allocator. There you go. Duh. Maybe I could call this VMA allocator actually. And yeah, pretty much. Lovely. Love that. And in fact, I could do the same with this guy. And there you go. Lovely. And yeah, that's pretty much it. Let's go. So I've created our allocator. And next up, I'm just gonna set that to the VMA allocator. Very nice. Now let's see if this all works just as expected. And yeah, I probably forgot some function. So it says that vacay get buffer memory requirements isn't there. 2khr. Alrighty, well, let's see why that is the case. Well, I'm setting it here though. Oh, I see. Hold on. I guess I understand what's the problem here. Oh, I see. Now, since I'm using Vulkan 1.3, I don't really need to pass in the KHR versions. Is it? What? Oh, well, I am setting it to version 1.3. Well, what happens if I actually just done something like this for now? Buffer memory requirements. Weird. Okay. I mean, I could just add the extension, but it shouldn't be using that. It should be using the core functions now. Alright, let's see what's happening here. Let's try to define this just in case. I'm gonna go with Vulkan 1.3. Gonna make sure to do the same with here. And let's try it again. Yeah, it's still checking for that stupid thing for some reason. Interesting. I really don't know why that is the case. Well. Okay, let's see what's happening here. So if VMA dedicated allocation or VMA Vulkan version greater than or equal to that, if M Vulkan, well, where this is coming from, MU's KHR dedicated allocation, but how does it actually know? Use KHR dedicated allocation. What? Maybe I'm setting up something wrong or what? Can be set only if mVulkan API version is less than VK make version. Alrighty, well, what if I run my debugger real quick? That doesn't help. Though, what if I have done it here? Doesn't help either. Oh, never mind. I gotta actually do it here. There you go. And let's see what we got here. Well, it's false. So Yeah, it's false. So why it's actually doing that? That's stupid. Hold on a second. Just keep it going. Well, in fact, let me go to here. Well, not here, but come on, are you kidding? Go to here, right? And let's just see what's happening here. Okay, and then debug. So it's checking if Vulkan version is greater than or equal to. This doesn't make any sense. Use KHR. Oh my god, I think I know what's happening here. Well, what happens if I actually just give it the non-KHR version? Just like this. And what about, for example, this? Maybe this. This. Okay, let's try this now. Okay, let me remove this guy. And I believe maybe it would work now. Alright, it worked. Let's go. Yeah, my bad. My bad once again. But I honestly don't know why they even look for that KHR version, since I'm using Vulkan 1.3, which doesn't use the KHR. It doesn't need to. It should actually use the normal version. But what I've done for now, I just gave it the actual valid Vulkan core function as extension, which should be fine because it's just an alias. Since this function have been basically promoted to core in Vulkan 1.3, so I don't need to add it as an extension essentially, but I still need to tell it that this is KHR. But anyway, who cares? So whatever. So this works lovely. So now we get an allocator. Now it is actually very simple to allocate memory for Vulkan optimally. As you can see, just buffer info, size, usage, alloc info, alloc usage, and just create a buffer. There you go, and then you can fill it with vertices, etc, etc. Lovely. That is very nice. All right. VMA destroy buffer and destroy allocator. Okay, and the last piece here is to just destroy the allocator and, well, render allocator. And that's basically it for that one. Now next would be to actually create the surface, and in fact I'd like to create the window and the surface after we have created the instance essentially. So here, before we select a device, physical device, because later on we may want to actually, depending on the surface, we may want to check some stuff, some compatibility, like the compatibility between the physical device and the surface, etc, etc. So I'd like to do it here. Alright, so right now we're gonna actually create a window. So SDL window is equal to SDL create window. Lovely. And then the title. Now here we're actually going to use our create info thing, right? So create info dot not in used, but this time it's going to be title, and then create. Well, honestly, I'd like, well, in fact it is already the case. Yeah, so I'm just going to use it like that. And what is that C there? Oh, I see. Create info with, that's gonna be, or actually it's gonna be basically dimensional, well, logical dimensions dot x, or I'm not sure. Hold on. Go back to render H or whichever. And here I'm gonna say title. And I'm also gonna say the dimensions. Well, GLM Vic 2 or something. How do you actually use that? Like this? Yep, it is. Okay, so it's basically just Vic. It's basically just an array. Yeah, pretty cool. But I don't want an array of floats though. I want an array of unsigned 16 bits, or at least unsigned integers though. Vic 4. I don't think maybe they have. Yeah, probably they don't have it, I guess. At least UVic 2. No, they don't. Interesting. So yeah, we're just gonna go ahead and say, I guess, U16T or uint 16, right? And this is gonna be an array of 2 dimensions, right? And I'm saying logical dimensions just to remind myself that this is not for pixels. Like, it's not how much pixels for the window, but really it's about it depends on the scale of the monitor, etc., or whichever. But anyway, and I'm saying 16 because, well, you don't want to go more than that, really. So otherwise you may probably break it. So yeah, and here I can just say 0, create info, logical dimensions 1. Now here you enter 2 flags. So for you enter 2 flags, or honestly, just to simplify things, we could just go with the IVEC2, you know, fine, whatever. And then, although not ideal in my standards, but anyways, so for the window it's gonna be hidden at first, at least I'd like it to. And let's not forget about making it vulkan. So window vulkan. And why I want it to be hidden? Well, essentially, compatible pointer to. By the way, to actually support Android and to support Mac OS, we gotta do some crazy stuff. It's not very hard, but I'd like to not care about it right now. So, incompatible pointer to integer conversion passing IVEC2, aka to parameter of type int. What? Weird. Can you run this? Oh yeah, remove that stupid in-use thing. Hold on. Did I save this or what? Oh, I see, makes sense. So here let's just set the title to Codoxel and the dimensions to, well, 800, 600, I guess. But why it's like this? This is weird. Hold on. Oh, I see. That makes sense now. Makes sense. Alright, so this should work now, hopefully. If I run this now. In used variable window. Well, that makes sense. So after I'm done with my initialization, then I'm gonna go ahead and say show window. So I don't show the user like just a garbage window. I'm gonna show it as soon as I start rendering something. Well, at least as close as possible. Initialization could take some time. So in save buffer access, what? This is so weird. And save buffer access. I know it is safe, so who cares? I mean, they got a point, but bruh. Yeah, this is gonna be very not so useful. I mean, it's gonna be useful in some cases, but not here, especially since I'm gonna be using such vectors a lot. So, bro, no way. CMake list. And time to add another warning into the blacklist. I-W, no. No way. And this should work. There you go. We got a window. Nice. And what's next? Well, what's next? It's gonna be... Alrighty. Hold on a second. Engine init. Okay, I see. Now, where is engine.h? Alright. Now, here is the deal. For now, I don't know if I will really want to give the access to the launcher. I don't care about that, honestly. So let's just say struct engine though here. And then here we're gonna have a renderer. Essentially. And what I'm gonna do here is, well, I mean, yeah, I gotta do that actually. I gotta do that. Right, so go back to engine.h. I don't want to allocate memory for nothing. Oopsies. I have no idea what I've done there. What? Oh. Oh. Engine. Alright. And now it's basically a matter of actually... So basically engine init would take a pointer. Well, this gotta be first actually. Right. Though we could type div the renderer, but who cares for now. New line at end of file, fix available. Alright, that's pretty much it for now. And now in, where is it? In main.h, main.c or whatever that is, yeah. We're gonna have a little bit of a different thing. Though, hold on, did I actually... No, yeah, I forgot to actually update this. Alright, this is how it goes. Alright, so let's go to main.c now. And what we should do, now basically I'm just gonna create an engine and I'm gonna give it the address to it. And that's basically it. Oh, and now SDL not found. What? Are you kidding me? Engine.h, render.h. File not found. This doesn't make any stupid sense. Utils. Really doesn't make any sense. I mean, it's pointing me to the file. What? Safe? What is that? I don't know. Trigger breakpoint. Well, I have no idea why this is not going right. Well, if we go to the CMake stupidity, let's see. Engine include, so that's so confusing. Very, very confusing. Like suddenly it just decided that SDL doesn't exist. Let's see. Well, I'm confusion. Oh, where it's actually being included, but well, I think maybe I know what's going on here. Yeah, I see the problem now. So basically, utils is trying to include SDL, right? Now, who's including SDL? The render. Now, who's including the render? The engine. And who's including the engine? The launcher. Now, the launcher doesn't have SDL. Amazing. So yeah, I should try to basically, let's see, instead of having render.h, I'm just gonna say type def. Well, how do you actually do it? Hold on. Type def render, well, struct render. But to actually be able to do that, I have to make it a pointer, and that means I have to allocate memory for it. Well, oh my god, well, let's see. And if I do that, I'd have to do it for every single stupid thing. Well, do I really have to do it that way? No, well. That is very interesting. That's what happens when you try to decouple your project. Oh my god. Well, you know what? For now, I think what I'm gonna do is to simply just link SDL to the loiter, to the launcher, and call it a day. And with that, I could even get rid of that stupid stuff that I have here. Like, where is it? Yeah, all the stupid stuff. I could use SDL for that. Yep. Although I didn't want to, but well, what you gonna do? Let's see. Let's see. So target link libraries, and I'm gonna link it with, honestly, I'm just gonna copy the same, well, yeah, fine, for now I don't, anyway, never mind. And launcher, and let's go. Known type name. What? There you go. And what now? Cast from far proc to blah 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 blah. You know what, bro? Sayonara. See make list. W no. Bruh. And let's see. And finally worked. Oh my god. Well. Alrighty, let's see. So engine init. Now what's next? Render create. And of course we're gonna have, well, engine.h. Engine init. Oh, I see what's going on. Oh well. Yeah, at the end of the day, I'm just gonna say render Well, actually, did I really need all this stuff? Oh my god, I can't believe this. So I didn't need any of this stupid stuff. Since I don't have engine destroy and I don't want to add that either. So... oh well. Alright, go back. Go back in time. Okay. Oopsies. Well, hold on a second. Engine init. What I do want to have access to the engine now. Maybe? You know what? Never mind. Just go back. Well, go forward. Anyway, for now it's fine. Alright. Well. For now, let's just say engine destroy. But in fact, we gotta do it in... let's go engine.h and let's say DLL export void engine destroy. In fact, I'd like to say engine create instead. Yeah, that would be nice. And yeah, engine. And yep, well. And inside of engine.h, well, inside of, well, main.c, we gotta change all of this now. Well, in fact, I think I could probably right now, since I'm linking to SDL anyways. I remember there was a way to actually load the library here. Load object. There you go. Dynamically load a shared object. Cool. So the SO file. Hold on, I want more documentation. Come on. Why it's super slow? Come on. Seems like SDL website is trash. There you go. Oh well, never mind. Can I just check this out maybe? Bruh. Okay, here's the deal. SDL load object, I'm gonna say engine, well in fact Codoxel. Can I do this? Not sure. Well, what happens if I do this and I do that? That's some great timing right there. Lloyd object void I guess. Yep. Lloyd function and Lloyd objects. By the way, what was the advantage to using Vulk over the default Vulkan loader? As I said, instead of having to... Well, I'm using the Vulkan loader. I am using Vulkan loader, but the thing is, I'm not linking directly to the Vulkan loader. I'm linking it at runtime, first of all. And second of all, I'm loading instance specific functions and driver and the device specific functions, which allow me to rule out, when I created the device, I can rule out the loader altogether. I don't need the loader anymore. I basically call to the driver directly. So yeah, which is quite important for functions that you're gonna be, running every frame. So yeah, use of declared identifier engine init. Engine create SDL load object. And what else? Get proc addr engine init. Well, this is basically, yeah, Codoxel, okay. Well, it's gotta be called the library, why not? Now SDL, well, not SDL, but fail SDL if not library, right? Then fatal SDL, and then we have an engine create, and then finally engine destroy. Honestly, okay, never mind. So if I understood that, the default loader has one layer of indirection. In fact, 2 layers, but yeah. And with Vulk, you get rid of that indirection, is that right? Now let me show you one thing. If we go to so it's still not working anyway. So if we go to Vulkan loader there you go. And if I go to, there you go, best application performance setup. Now here is your typical Vulkan application with the using the Vulkan loader directly. Here's your application, here's the drivers. So your application calls into, when you call a function, you call into the loader trampoline, which basically redirects you to some function. Now if you have some layers enabled, like validation layers or whatever, you have to go through those layers. Here's layer A, here's layer B, and then layer B calls layer C, and then layer C calls loader terminator. But let's say that there is no layers, which should be the case in release mode. You're not enabling any layers. Then that means you're gonna have loader trampoline and loader terminator. Now loader terminator would have to also figure out which driver you're talking about, or in fact it would basically broadcast for all drivers, maybe. Depends really, I guess. Alright, so now this is the first, like the global functions. This is what happens when you're calling into the global functions. Now if you use Vikigate instance proc addr, which I'm using indirectly using Volk, using this guy, hold on, render.c, where is that? Render.c. If you noticed, I'm using, yes, this guy, Vocaloid instance. After doing this, you get rid of the terminator. Okay, so because do you, hold on, actually this is also the instance, maybe. Yeah, this is just, I guess, the instance, so forget about this. But then, well, hold on, super confused now. I guess this is the, anyway, who cares? Who cares? But basically, next level, you get the loiter trampoline only, but you get rid of the terminator because you know exactly which driver you're looking for. There you go. So now you have one layer of indirection instead of two. Now the next level, when you use actually Vikigate device proc addr, which I'm actually using indirectly by using Voc Lloyd device. And in fact, I can show you that. There you go. It's using Lloyd, and Lloyd is what? I don't know all of these redirections. This is so stupid, but anyways, so basically this Vocaloid device is supposed to call Vikigate device proc addr on that device that I created, and after that happens, instead of having this one layer of redirection, if we don't have any layers, then the application would call directly into the driver, basically. So we have gone from this 2 layers of redirection at least to 1 layer to 0 layers of redirection. We're calling directly into the driver, and that's basically it. So yeah. Alright, so where we was actually, render, create, engine, and engine.h, yes, and let's now do this maybe, and then render. Where do you find these resources? Well, good question. You just find them. Just with time and some research, from time to time you learn something, pretty much. But a lot of these things that you wouldn't learn in a typical tutorial, Vulkan tutorial. But yeah, render, but you just gotta dig basically. Nice, thanks, I'll clip it for reference. Alrighty, you're welcome. Use of undeclared identifier render engine. Render. I guess. Okay. And yeah, I should rethink a lot of stuff, honestly. But anyway, what's next? Can this work? In the find symbol engine create, and in the find symbol engine destroy. Well, that makes total sense since we're not linking directly to it. So what we gotta do is DL Lloyd function, I believe. Yes, and you gotta give it the library, and then you gotta give it the name. Now the name in this case is engine create, and yeah, so pfn engine create is equal to this, and of course as always cast this guy. Now if not engine create, you have a problem. In that case I'm just gonna say fatal SDL, and basically same thing with engine destroy. Engine destroy, and now if not engine create or engine destroy, then fatal SDL. And there you go. Lovely, it works. Now let me make sure I'm doing this right. There you go. Let's go. That was so fast, isn't it? So as you can see, I'm destroying the device and destroying the instance, which is correct. Is there any problem with validations? No problem. Lovely. So we're ready to the next stage now. Nice. Render. Well, not the next stage, but well, you got the point. Anyways, so engine.c. At this point, I'm just super tired, honestly. But I'm so excited but tired at the same time. So I have no idea. And I'm not having a break anymore, so okay. Hold on a second. Okay, it's fine. Trigger breakpoint. Okay. So now what? At this point my brain have lagged. SDL show window. VMA allocator. Yeah, I pretty much need the surface and the slope chain. So did I create the window? Yes, I did. And I didn't check for error handling. If not window, then what you gotta do? Well, fatal SDL. And what else? Now we gotta create the actual surface. So SDL surface. Not SDL surface, vacay surface, right? But yes. And here where Android needs some special thing. Basically, in Android you have to recreate the surface. When you quit an application in Android, you basically have lost the surface and you have to invalidate it. And when the user go back to your application, now your surface can be recreated or should be recreated, so you can use it again, basically to render. I'm not gonna care about that now. SDL, well, yeah, SDL creates surface, and then here you need not that. SDL vulkan creates surface, and here we gotta pass in the window the instance that we have created, and then here it's gonna give us the surface, and it's also gonna give us a boolean value. Now basically, if not this guy, basically if it fails, then well, you know the drill. Fatal SDL. And yeah, now we got our surface pretty much done. But of course, we gotta destroy the surface before destroying the instance. So vk destroy surface khr. The one problem with the SDL create surface is that it doesn't take vk allocation callbacks. So you're just forced, if you want to use that, you just cannot. unless if you fork SDL and do that yourself. But we're not using them currently, we're just using null anyways, so yeah. All right, so render, but they're probably gonna change that. There is a lot of open issues on GitHub, but anyways, about Vulkan, some of them are mine. Well, hold on, let me show you. Let's see, SDL, GitHub. There you go, and there you go, Codotaku, let's go. Add a Vulkan utility function to query physical device presentation support without the surface. Oh yeah, I have created it in C++ basically, and X11 directly for this case. As you can see, add a Vulkan utility function to query physical device presentation support without the surface. I found absolutely no resources on how to do this, so this is just my take on it. My recent C++ project. It's also tested on platforms other than Win32. Now the problem with this is that it's not entirely, like, its results aren't entirely reliable. You still have to actually use, but it gives you an idea. It gives you an idea of the support. But yeah, but it's not the best. All right. Other than that, there is also SDL Vulkan get instance extensions pass pointer without copying. SDL Vulkan get instance extensions currently expect the user to allocate memory so it can copy the array of extensions to it, while it can just pass a pointer to the internal array and leave the freedom to the user to either use the pointer directly with Vulkan in the case of not needing other extensions, like what I'm doing currently, or allocating his own memory, copying it himself. Pretty much. Currently the signature is this. I suggest turning it into this, similar to other APIs like GFW. There you go. Return SDL bool in the previous version was necessary. Now we can just return a pointer to the internal extensions array, or null in the rare case where it is not possible. Pretty much. Too simple, huh? Alrighty. I think these are pretty much the ones I've opened myself. And there are ones that are already opened by some other people, so I didn't bother to duplicate the issue. So where is it? For example, yeah, there's this one. Implement application state for, well, this is not directly to Vulkan, but it is related to it. This is about the surface recreation, etc. Well, not directly, but they're talking about the on resume and on, well, the application state, which tells us when you know, on Android, when you quit the application or when you launch it up, basically. So they're talking about some stuff here. It might make application development easier to have the foreground and background application states in desktop application as well as mobile applications, because currently SDL only gives you events on mobile applications and on desktop it doesn't. However, there isn't really the same foreground background concept on desktop, and if you want to emulate it, what should it map to? So basically what I said to them, the only use case of those events for me is to handle Android AGL surface creation and recreation. I suggest for other platforms to have the events trigger once at the start and end of the application. At least that was my suggestion. Honestly, cleanup doesn't matter that much in events, so I'll have cleanup after the event loop anyway. The only really important thing for people like me here is receiving the foreground event at the start of the event loop, or at least having a function to check if we'll even receive a foreground event or not. Otherwise, currently I have to use the macro Android, which may be fine but less than ideal. Alright, I thought to add a snippet of my use case for those events in case it helps. There you go. So this is how you handle it in Android. You have an optional surface because, you know, you're going to be recreating it. So if not defined Android, then you, of course this is using C++ here. So surface in place window instance, so I'm essentially creating a surface from the window in the instance and then showing it up. And essentially, if defined Android, I'm looking for these events, and if I get this event, then I'm creating the surface or recreating the surface. And then here, if I get this event, I'm invalidating the surface, pretty much. Would be nice to get the foreground event near event loop start in desktop. The background event doesn't matter in this case for desktop, but it would be nice to get it near the end of the event loop. Otherwise, a more general solution would be to at least add a function that can query if the underlying platform will ever emit background and foreground events. P.S. That is a Vulkan surface. Alright, anyway, so yeah, what else? There was there was some other things. More faster SDL. Sports Vulkan on Haiku. Interesting. So I guess maybe right now currently SDL only supports these for Vulkan, basically, and he's suggesting to add the Haiku. Yeah, I don't know why they're actually restricting the platforms. At least that's what I understood. Anyways, right. Oh, so this is actually not existing in SDL? That's interesting. There you go. This is what I talked about. Can call vacant destroy service catcher on their own, but to do that, the programmer must know that the vacant allocation callbacks used during service creation was null. This is currently the case, but isn't guaranteed to be the case. It's probably easiest if SDL just offer a matching destruction function for each creation function. But they pretty much just gotta actually give you the you know, you need to be able to pass that. Well, we could maybe do some live stream trying to improve SDL, maybe. Window shape. Okay, pretty interesting stuff. So yeah, that was just a tour about what's going on there. Alright, so at this point I'm very tired, but render surface, well, we don't have the surface. Well, in fact, let's go to render.h, and before the physical device, yes, here I'm gonna have, well, first of all, my SDL window, and second of all, my vacate surface. Now ideally you would basically separate the concerns, separate the renderer from the window stuff, and so ideally in the renderer you wouldn't have an SDL window, but who cares, it just makes my job much easier. So it's all about making it work. So anyways, surface kchar. Okay, so that's pretty much it, I think. Surface. Nice. Now we're gonna destroy two few arguments to function call. So here the surface. Well, in fact, here I should have actually done instance, right? And then here the surface, and then here the allocation callbacks. Now, as he said, I can't really know allocation callbacks in this case what it is unless if I look up the documentation of SDL. Now, in my case, I already know that it should be null. They're just hard coding it too, just like what I'm doing here. So that's fine. Okay, what else? I'd also like to destroy the window. And to destroy the window, I'm gonna destroy it here. Okay. There you go. Lovely. Also, another thing that I kind of forgot about. If you go to main.c, now we could basically get rid of all this platform dependent stuff. And look at that, the power of SDL. 20 lines. Engine create, engine destroy. Library. Wait until I see how you can create a window without SDL using XCB and Win32. I actually tried it. So, anyways. Lloyd object. Now SDL in Lloyd object. Right. Codoxel. Well, here library. Right. Lovely. And that's pretty much it. Okay. So what else? Is there any questions so far, by the way? Is there any questions? Win32 API is... oh well. It's actually not that bad, honestly. It's not that bad, but it's just too much work. I mean, it's not that bad after you got used to it, you know, after you got used to the pain, you know. Just like how you get used to CMake and how you get used to C++, you know. It's pretty crazy. It's like, I just wonder how a beginner, when it comes to the programming world nowadays, how a beginner would even start, bro. Like, bruh, come on. I just like have all of this experience and I still find a lot of things hard. Like, I have no idea how a beginner would even... And the problem, you see that, yeah, C and C++ are hard, right? But when you even go to something like JavaScript, now, yes, JavaScript itself, possibly easy, right? But then suddenly you enter another sea of frameworks and technologies and libraries and stuff that you all have to learn to... Like, bro, come on. Really? This is what programming have become? Well. Then you go to Python. It's the same story. You have to learn all that crazy stuff. So nothing is pretty easy, honestly. It's you just have to essentially choose what is fun for you, I guess. Right. All right. Anyways, so now what we should do, yeah, we need to create the stupid swap chain. All right, and well, Honestly, at this point, I think I'm just gonna end the live stream. I'm so tired at this point. So, yeah. I'm going to commit all of this. Please feel free if you want to clean this up or improve something or whatever. Please just submit a PR in the repo that I have published. I'm very welcome to PRs, especially the ones that are improving the code that already exists, even if it's so small. So let's see, where's the stupid thing? Hold on. GitHub. Let's see, Codoxel. The only creative name I came up with. I'll start contributing later. I'm so busy this week. Feel free. No pressure. Add a readme. Well, no, I don't want to do it here. Yeah, sure. I'm gonna add it here actually. Readme.md. Alright, let's go. This is as readme. Very cool readme, isn't it? Stage alt changes. Alright. My code currently is spaghetti, but hopefully once we get something working, we could do the janitor's work in our code. So yeah. Stage changes. Message control enter to commit on master. Ready. Good night. Committee. So is everything good? So this is what we changed so far. Bye bye, good night. Vacate malloc. We have changed this, change this, change this, this. So yeah, pretty much. So now I'm just gonna commit, I think. Sync changes. Okay. And yeah, the code is live. You could try on your computer and also let me know if something doesn't work. If you're too lazy like me, then at least open an issue, possibly new issue, and tell us what is the problem and we can try to solve it hopefully. Otherwise, if you're feeling adventurous, then you could do a new pull request. In fact, you gotta first of all, fork the project. Basically, you gotta fork it like this. You gotta do fork, clone the forked project into your system, and then just open it on VS Code, do your edits, commit it to your fork, and it's quite a lot of work, but if you're used to it, it's pretty simple. Otherwise, if you're too lazy but you're still not that lazy, what you could do, for example, is just go to here, for example, do this, and just change the code here. Too simple. And yeah, so that was it for this live stream. We had some fun. So yeah, thank you for tuning in. The next level of laziness. Yeah, at this point I'm just super tired and super lazy. Star, please make sure to star. I'm the first one to start my project. Let's go. And yeah, that was it for this live stream. Take care and have a good night or good day or good evening. Goodbye.